Yeah, just watch the...
Okay. Today we're going to talk about combustion. Okay. Does anyone know what the key ingredient for combustion is? What is the one chemical that we absolutely have to have for a combustion reaction to take place? Reagan.
Fire.
Okay, fire is the oxygen. Fire is the physical outcome of combustion. We know combustion is taking place if we see the heat, we feel the heat, we see the light, okay, together, we see fire, we know combustion has taken place. But combustion is not fire. Combustion is the combination of chemicals, one of them being oxygen. Okay? So, this is isopropyl alcohol.
Are you gonna light it on fire?
Okay?
Yes.
Set it far away. Okay.
Wow.
Now, we see the light, we feel, or I can feel the heat. Okay? There's a visible reaction taking place. Okay? But what is necessary for this to happen?
Oxygen.
Oxygen is necessary. If there was no oxygen, okay, if there was none whatsoever, what would happen to this reaction?
I know. There would be no fire.
What would happen? Yeah.
It wouldn't work.
It wouldn't work. Okay?
The fire's dying. It burned up all the alcohol, that's why.
And actually, let's do this. Let's make a small version of this fire. Okay?
In a jar.
Put a quarter in. It's fire in a jar.
That'd be cool to put it in
It is.
that. That would be really
It's
cool.
going to cut off the oxygen.
Like put it around.
Okay? Is it happening inside the beaker?
Nope.
No.
No, it's not.
Going
I don't recommend
But it
touching
cut off the
beaker.
oxygen.
Okay, you can touch it.
Now it's happening. If I go ahead and put a bigger beaker over top of this, it quickly extinguishes the fire inside.
But there's oxygen getting in on
Okay,
the lip of
but
the beaker.
now there's a little bit of fire. And now
You're magic.
there's a lot. So oxygen is a necessary component of combustion.
Okay, that's
Okay?
cool.
It's a necessary
It's like a
component.
What if you kept it on there like all night and then did that in the morning? Would it? I guess would it still work?
No.
Or would it just? Because the
No, there has to be a little bit of flame present to reignite the reaction. So oxygen is necessary. Okay? I want to show you this reaction that I just did, and then I'll show you something else. Isopropyl alcohol is carbon, hydrogen, and oxygen. So the same ingredients for sugar, but in a different combination. Okay? So C3H8O, yeah, I'd recommend this. This is isopropyl alcohol.
wouldn't it be okay? Say that 5 times fast.
You spell it out.
Yeah.
Isopropyl alcohol. Isopropyl alcohol, okay, is a carbon, hydrogen, oxygen substance. So like C6H12O6 is a type of sugar, okay? Sugar and alcohol have the same elements, but they're in different combinations. This is C3H8O, and because of this combination, it's isopropyl alcohol. When I combine it with what substance necessary for combustion? Parker? Oxygen gas, O2. It reacts to produce, okay? It reacts to produce H2O and CO2. It produces water. Does it produce a lot of water, do you think?
No.
Not a lot. Water absorbs lots of energy. That's why we put water on fire. Okay? But fire does, oftentimes combustion, I should say, not fire, combustion does produce water, but it produces water vapor and in very small quantities. Okay? Yeah?
Well, it would definitely produce more than one water molecule because that isn't balanced.
Okay. You're right. It's not balanced. I'm not going to ask you to balance one that's this hard, but I'm going to show you how I would do it. Okay? So, this is isopropyl alcohol, oxygen gas, H2O, vapor, water vapor, and carbon dioxide gas. And so this is how you would balance this equation. Okay? The first thing I would do is I would look at the carbons and I would say they're not balanced. I have 3 here, but I only have 1 here. So I'm going to start by putting a 3 out in front so that my carbons are balanced. The trick to balancing a chemical reaction is to take it an atom at a time, or a substance at a time. Okay? So now my carbons are balanced. So now I move on to hydrogens. I see I have 8 here and 2 here. So I'm going to put a 4 here, and now I have 8. Okay, and the last element that I have to look at is oxygen. And so I see I have 1 and 2, that's 3, and 1 and 2, that's 3. Okay? So now I got to go back and double check that everything, oh, no. Mr. Bornheimer's bad. I have 1 and 2 is 3. I have 4 and 6 is 10.
That's
That's definitely not balanced. So, Mr. Bornheimer has got to do some stuff. So, what I have to do is I have to say, okay? In a situation like this, when I see that I have an odd number of oxygens on this side because of this O, there's a trick you will learn later, okay? But basically what the trick entails is doubling all of your numbers, okay, or doubling the ones you've changed. So I'm not going to try to explain the trick, but what I'm going to tell you is that this becomes a 6, this becomes an 8, and now I have to work with these numbers. If I have 6 carbons here, I have to put a 2 here. And if I have an 8 here, okay, that gives me 16. I have 2 times 8 is 16. I'm good on my carbons and my hydrogens. Now, Connor, I have 2 oxygens and 2 oxygens. How much is that? 2 and 2. Oh, yes, sir. It's 4. And over here, I have 8, and 6 times 2 is 12. 8 and 12 is 20 oxygens. So I can maybe adjust this guy. Okay, I have 2 here. So 20 minus 2 is 18. Is there any number I can put in front of this to get 18? What do you think? Gabby?
9.
If I put a 9 in front of this guy, I now have 20 oxygens on both sides. I'm not going to ask you to do this. Just showing you how I would do it. So now I have 2, 9, 8, and 6. It's balanced. This is the chemical reaction that was taking place that you saw. For every 2 molecules of isopropyl alcohol, I had to consume 9 molecules of oxygen, and it put out 8 molecules of water and 6 molecules of CO2. That's what was happening. Now, when it was actually happening over there, millions and millions of atoms were being used up and produced. But isopropyl alcohol was being used up, oxygen gas being used up, and in the process, I put a little bit more water into the room, I put a little bit more carbon dioxide into the room. So this is great because, hey, it's like having our own personal humidifier, and hey, plants would love it because there's some CO2. Unfortunately, we don't have too many plants, if any. Okay, so.
You and me.
Oh, God.
Okay, let's get, so this is what was happening. That is a combustion reaction. What about underwater or in outer space? There's no oxygen available underwater or in outer space.
You can add your own oxygen.
Oh, Parker Morty. You can bring your own oxygen. How do we do that?
Oxygen tank.
Okay, we can take oxygen tanks. So in outer space, in order to have a rocket booster go off, in outer space there's no oxygen. So if I put a bunch of fuel and I spray it out the end of the rocket and there's no oxygen, it's going to be like fire inside the beaker. Nothing's going to happen. But what if I spray oxygen into the mix? Will combustion take place?
Yes.
Yes.
That's why they have those tubes on the side, because those might are filled with oxygen, oxygen, and then they break off in space and they go.
Yeah, that's fuel as well. But the fuel is kind of mixed with the oxygen so that it can provide its own oxygen. What about underwater welding? Or like if you take a road flare and you stick it in water, it burns. It keeps burning. How do those work? Yeah, Parker.
Probably because in like the fuel, like you said, there's oxygen in the fuel, and there's oxygen in the fuel.
Right, there's oxygen in the fuel. So if I have a road flare, they're designed to work in case it's like snowing or raining or even underwater. So if I take a road flare, which we use in all kinds of situations when things are dangerous, we rip that road flare, we light it, and it's burning. I could stick it in a 5-gallon bucket of water and it'd keep burning because it's providing its own oxygen so the combustion reaction can take place. Okay, that's how we do underwater weld and all kinds of things like that. Okay, now,
Wait,
This is kind of, yes.
is this combustion what happens in cars to make it move?
Yes, and so cars also need oxygen. So your car actually has what's called an air intake. It takes in air so that it can ignite the gasoline.
Well, that's
But then how does
that's
it not?
your grid.
How does the car not blow up?
It only ignites a little bit of gas at a time. Like the equivalent of maybe just a little bit on the end of your finger.
What is
Then
I
it
saw
comes
do
to
that.
like makes it like go up and down and then it moves.
Yes, yes. What's your question, Grace?
I still don't get like the oxygen spray and blah blah blah. But how do you even spray it in? That's the thing.
How do you spray it in?
You
You ever had a fan?
You keep saying spray it in, but what does spray it in mean?
You take oxygen in a tank and you release a little bit. Have you ever filled a balloon with helium?
no?
Isn't that releasing a little bit of helium into a balloon?
Well, yeah.
Same idea.
Well, how do you? I think you said oxygen. You can't like separate it or something like that. Like.
Okay. This is water. Okay, if I spray this water, am I separating the water?
No.
No, I'm just spraying it so that it's a mist instead of liquid, right? Okay? So if I spray the water, okay? If I spray the water, is it still water? Yeah. So if I have to have a rocket booster, if I have to have a rocket booster, oh, it's fine. If I have a rocket booster that needs oxygen, can I just take some oxygen along and release a little bit at a time? And then that powers the chemical reaction? I'm not separating the oxygen. I'm just releasing a little bit of it at a time. Does that make sense?
Yeah.
Does it make sense, Harry?
Okay, it is just water, ladies and gentlemen. It is just
No,
water.
it isn't.